Hi everyone, this is Brian McLain. I am going to be your student's chemistry teacher for the 2020-2021 school year. And I wanted to go over some of the things in the class, both in terms of COVID-19 and how things will be a little different this year, as well as just a general overview of the class and the things that we're going to be talking about, and some helpful hints and helpful discussion, hopefully, on how best I can serve your student and how best you can help your student, and to make sure that they succeed throughout the chemistry year. So first of all, my name again, Brian McLain, and just a little bit about me here. I'm going to make sure this works properly. There we go. It's working okay. A little bit about me. I have a Bachelor of Arts in Biochemistry from Oberlin College. I have a Master's of Science in Science Education from the University of Akron. I worked in industry for a little while for Veolia Environmental Services as a quality control technician and chemist. I actually set up an ethanol reclamation unit in Medina, Ohio. That was a long time ago. It was not the most fun job in the world. I much prefer teaching, and so I went into teaching after that. I do have some research experience. I worked in the microbiology department at OSU for about a year, working on mRNA transcription, how that affects antibiotic resistance in various types of bacteria. This is my sixth year at Granville High School and my seventh year overall teaching chemistry. So that's not all just kind of to make you feel like, oh, he's really smart or anything like that. It's just to tell you that I know my science. I'm very proud of my background in science, and I think that my background helps your students do really well because I know what's going on in the sciences. I know how to talk about the world that is the science, both from a content standpoint as well as the kinds of people who work in the sciences. So I use my knowledge to make sure your student is learning the best that they possibly can. Okay, so chemistry is a class. A lot of times chemistry gets a rap that it is very hard and all about memorization and things like that. I couldn't disagree more. I will never disagree, though, that it's challenging. It is definitely a very challenging course. And as you can see here, chemistry is, as a definition, is the science of the interactions of matter. So when you look at a picture like this here, you can see that this is a salt lattice, sodium chloride, and this is what happens when salt dissolves in water. A lot of people, they just put sugar or salt into water, for example, and they don't really think about what is happening at the atomic level. Well, water molecules are interacting with the ions here and moving them out of the crystal lattice and starting to scatter them, mixing them in with all the water molecules. And there's tons of things happening, a lot of energy exchange, and there's a particular way that the water molecules are going to orient themselves based on different properties, something particularly called electronegativity. There's a lot of things going on, and all of this you can't see. That's the problem a lot of times for students in biology. They can look in a microscope and observe cells. They can watch predator-prey relationships either in a movie or in real life. In physics, they can roll a bowling ball down a hill and watch it hit pins. They can watch a car move around. They can talk about a cannon or fire a potato gun and watch how it moves parabolically. But in chemistry, we can't show them what's happening. We can see it from an observational standpoint of like, okay, the salt's dissolved in the water, but I can't show this to them. I'm not Ant-Man. I can't shrink everyone down to look at the subatomic world and look at what's happening. So there's a lot of things, there's a lot of modeling in a chemistry course. There's a lot of drawing pictures and understanding some very basic foundational principles about what these elements are doing and why they are doing it. There's a lot of math involved in chemistry, lots of math involving how much stuff is present in this solution, or how much stuff is needed to produce this much energy when we burn this. Something like that. There's a lot of calculations involved in chemistry having to do with the amount of matter involved in doing some kind of reaction. Now, a lot of students say, well, chemistry is a lot about memorization. And to some extent, yeah, there's some memorization. You got to learn the periodic table. You got to remember that Fe is iron or that C is carbon. But beyond that, there isn't that much more to memorize. Really, the important thing to learn in chemistry is that, like I was saying, there's some basic fundamental principles about how matter interacts with itself. And you can follow those principles day in, day out in order to understand what is happening. And so, like this picture I'm showing you right here, this is very complex looking, but from the perspective of someone who understands how water is set up, it's not that crazy because, okay, positive, negative. Oh, look, the chlorine right here has a negative charge, and the hydrogens on the oxygen are positively charged. Well, that makes sense that the hydrogens would be orienting themselves closer to the negatively charged chlorine. That's just kind of a fundamental thing. We know positives and negatives, they're attracted to each other. Their opposites attract. That fundamental principle, that one carries throughout the entire year. And that's not something you memorize. You just kind of go, oh, yeah, that makes sense. Positive, negative, opposites attract. That's a thing that needs to be known throughout the whole year. And so students should try to really get a handle on the fundamental principles that carry throughout the whole year. And as long as they can hold on to those things, it's not about memorization. It's more about, oh, okay, this is sort of common sense. Because as you get further in sciences, it's less about, okay, understanding the weird stuff. It's more about, oh, bringing it back to foundational principles that always are true. And so that's what the student really needs to do in chemistry. Now, chemistry during this pandemic, it's really weird. We are not going to be doing any hands-on labs this year. We are only going to be doing digital labs, so either simulations or demonstrations. Primarily, the demonstrations will be through a video. We've got a platform called Pivot Interactives, that is from Vernier Software, and those guys mostly make our different temperature and pH probes and things like that. But they've set up this really cool platform where students can watch a lab happening, and then there are different questions and analyses that the students can do. So because we can't have students really close together in the lab stations, and they can't be sharing beakers and graduated cylinders and test tubes and strikers and Bunsen burrs and standing next to each other the whole time. And labs are also, for the most part, they're not short. They're like 45 minutes a pop. And so for our safety, I'm not going to have students close together during that for a lab, and Mrs. Moon, the other chemistry teacher, agrees with me. So labs are going to be online, or I might demonstrate one at the front of the class. Homework this year, I hand out problem sets and students work on them, and then they submit them the next day or a couple of days from afterwards. This year there's not going to be any paper, so students will actually submit their work online. I'm going to set up a system where students take a picture with their phone of their homework. They'll see the problems on the screen. They'll write their work out on their notebook paper, and then they can do the problems, or they can show the problems on Schoology with an uploaded submission. So that's what's going to happen with homework this year. It's just going to be a lot different. This is going to be a weird year, but I'm going to make sure that students learn the best they possibly can. Now, to do well in chemistry, what does a student need? Pretty basic. I'm a pretty old-fashioned kind of teacher in a way. There's not much more you need than a notebook, a good notebook to take notes in, and the most important thing really is a calculator. You got to have a good, solid calculator. TI-84 is really probably the best one to get, but if you have anything else, it's perfectly fine. Just something that you can do your basic plus, minus, times, and division, maybe some square rooting and squaring, that kind of stuff. But a TI-84 is probably the best, and most likely if you're an Algebra 2, you're going to be using that all the time, so you might as well have that with you as well. Please make sure, parents, that your student has their calculator every single day in class. Students who forget their calculator, they just find that over time it makes it harder and harder throughout the year. And this year, we can't be sharing calculators, so I can't give them one. So they need to bring their calculator to class every single day. Like I was saying, chemistry is a challenging course. Something to keep in mind for you parents as you are helping your student. This is a class where math is used a lot, and a lot of times the math is different. We're converting between units. We're doing different kinds of calculations that seem weird to students, I think, at the onset. So please, if your student has a weak background in math, tell them to talk to me so they can get extra help. I'm very happy to help them. I want to show them the process of doing dimensional analysis because we're going to use that all the year. So please, if you're having a struggle of any kind, talk to me and I'll help you as much as I possibly can. Encourage your student to set aside some extra time for the course to study so that that student can succeed. This is not the kind of class where you can just kind of sit in, absorb the information, and then sort of just do well. You really have to practice it, just like a math class. A math class, you got to practice problems and do the work consistently. This is not really a class where we just read and learn vocab terms. No, it's more about doing the work and doing the analysis properly and really getting it into your brain. Extra help hours. So I have extra help hours on Tuesdays after school. Feel free to drop by and we'll go through problems together. And for those of you who are going to be online, please let me know. I just need to know to make a Zoom. And so if I don't know that you're coming, I can't make a Zoom essentially. So please, if you're working from online, then have your student contact me. Just let me know, hey, I'm going to be online for extra help for a Zoom. Just set that up for me, please. And I will make sure that happens. I think that's pretty much it. There are some online resources that I use regularly that I think are helpful for students. These two things, Khan Academy and Chem Team. Khan Academy, of course, one of the most, really just a brilliant website for going over stuff again. Kalan-san, he does a lot of the stuff that I do in the same exact way, the calculations and the setup and the analysis. So if you watch Khan Academy, you're probably just kind of watching me a second time. And then chemteam.info. This is a really great website. They mostly just have typed out explanations of problems. So they'll have like 20 or so problems on a specific topic. Let's say it's acid bases and pH calculations and stuff like that. You can find that topic on their website, and then they have like dozens and dozens of worked out problems. And so that's really helpful. I actually take some of those problems from their website and have used those in my practice problem sets. So those two things are really helpful. Again, just let me know if you have any questions. My email right there, bmclain@granvilleschools.org. Feel free to contact me anytime. I'm happy to help you out. I'll respond as quickly as possible. I'm going to be probably getting a lot of emails and craziness this year, but I will do that as fast as I can. Please let me know if you have any other questions in the future. This has been a very strange open house video to make. I hope you have an excellent day. Bye.